Hello everyone, welcome back to AE Amphi GOE 123. In this video, we are going to go through assignment 3 questions that are not covered in our tutorial. If you have questions when you are reading through the model solutions, you can follow with me to solve the problem step by step. Okay. Well, question P2.3. Find equivalent resistance between terminal A and B. This is the first type of questions we will see in the assignment. That's to find equivalent circuit. Well, for a very complex circuit like this, if we are going to find an equivalent circuit, that means we can simplify the circuit to be like this. Req. This is terminal A, terminal B. All of these resistors can be combined into a single resistor, that's Req. Well, so how can we do that? If we want to find equivalent resistor, it's most important to keep in mind the definition of parallel resistance. So what means that two resistors are connected in parallel? Well, two resistors are connected in parallel means the two resistors have the same two nodes. They share their two nodes, and then you can say they are connected in parallel. Well, so let's get started to try this question. This is terminal A, this is terminal B. My recommendation to solve this type of question is to start from a point that's away from these two terminals. For example, you can start it here to simplify some of the resistors. Well, let's say this is terminal A, and this is node B. And because there are no elements on this wire, so this is also going to be terminal B. So we'll first find these two resistors are connected in parallel according to our definition here. And that's 20 ohm in parallel with 30 ohm. That's 20 times 30 over 20 plus 30. And you're going to get 12 ohm resistor. So we can redraw the circuit diagram. Keep it like this. This is 4 ohm. This is our new 12 ohm. And this is 60 ohm unchanged. This is 40 ohm unchanged. This is our new circuit diagram. And this is terminal A and B. Well, at this point, you should be able to see that the 60 ohm resistor and 40 ohm resistor are also connected in parallel. So we have 60 ohm in parallel with 40 ohm. Use our formula, that's 60 times 40 over 60 plus 40. You're going to get 24 ohm resistor. So let's redraw the circuit diagram and simplify this part. We have here as a 24 ohm resistor. Well, at this point, you can simplify the circuit further. You will see the 4 ohm resistor and the 12 ohm resistor are connected in series because they are both connected to this point, but this point is not connected to any third node, so they are connected in series. And 12 ohm resistor plus 4 ohm is going to be 16 ohm. So we can draw the circuit. That's going to be 16 ohm. Well, for now, it's also very obvious to see the 60 ohm resistor and 24 ohm resistor both share these two terminals, so they can be combined as well. That's 16 times 24 over 16 plus 24. You again got the value as 9.6 ohm. So finally, we can simplify the circuit as a Req is equal to 9.6 ohm. So this complex network can be simplified to this simple one resistor network, and Req is equal to 9.6 ohm. Question P2.8. Find equivalent resistance between terminal A and B for all of these three circuit diagram. Well, the basic principle is the same, and we are gonna simplify the circuit layer by layer. So let's do the first one. Question A. Well, start from a point that's away from terminal A and B. You can start from this side. Well, you will see the 40 ohm resistor and 35 ohm resistor are connected in parallel. So 40 in parallel with 35 ohm, gonna 40 times 35 over 14 plus 35, we have this as 10 ohm. So we can simplify the circuit, so simplify this part to be a 10 ohm resistor. And let's redraw the circuit diagram. This is 10 ohm. Well, at this point, you will be able to see here the 12 ohm resistor and the 24 ohm resistor are also connected in parallel because they share both of these two nodes. So we have 12 in parallel with 24. That's 12 times 24 over 12 plus 24, and that's equal to 8 ohm. So you can simplify this part to become a 8 ohm resistor. So you have an 8 ohm resistor here. Well, then you are be able to see these three are connected in series. So that's 12 plus 10 plus 8 ohm. We have this as this is 20, this is 10, so that's going to be 30 ohm. So you can simplify this part as a single 30 ohm resistor, like this. This is 30 ohm. Well, then you will be able to see this 30 ohm resistor is connected in parallel with this 30 ohm resistor. That's 30 ohm in parallel with 30 ohm. You have 30 times 30 over 30 plus 30. And you will be able to know this value is 50 ohm. Then you can replace this as a 50 ohm resistor here. It's 50 ohm. Well, now the circuit become pretty simplified. So all of these three are in series. So that's 12 ohm plus 70 ohm plus 50 ohm is equal to 44 ohm. So the whole circuit can be simplified as a one resistor between A and B to be 44 ohm. So that's our equivalent resistance. Req is equal to 44 ohm. Well, then we can continue to do the second question, question B. Similarly, we asked to find the equivalent resistance between terminal A and B. We are going to start from a point that's away from these two terminals. For example, here, you have a 10 ohm resistor, 8 ohm resistor. They are in series. So we can combine these two as a 10 plus 8 to be 18 ohm resistor. And you can redraw the circuit diagram, and you'll find this 18 ohm resistor is connected in parallel with this 9 ohm resistor because they share both of A and B nodes. So you have 18 ohm parallel with 9 ohm. That's 18 times 9 over 19 plus 9. This will be equal to 6 ohm. So we can redraw the circuit diagram. This is 40 ohm, and this is 48 ohm. This is 20 ohm, 6 ohm, 5 ohm, 15 ohm. Okay. Well, we can continue to simplify. Well, let's start from another point here. You have 5 ohm and 15 ohm. They are connected in series. So 5 plus 15, that's 20. So we can simplify this as a single 20 ohm resistor. It's going to be 20 ohm. Then you can find that this 20 ohm resistor is connected with this 20 ohm resistor and share both of their two nodes. So they are in parallel. 20 ohm in parallel with 20 ohm. That's 20 times 20 over 20 plus 20. And this is equal to 10 ohm. So you can erase this and redraw the circuit. This will be a 10 ohm resistor. So now you'll be able to see this 10 ohm resistor and this 6 ohm resistor is also connected in series. And they both share only this one node, and this node is not connected to any other element. So we can combine this. That's 10 plus 6. You have a 16 ohm equivalent resistor. Now you have this as a 16 ohm resistor. Well, now look at this part. You have the 40 ohm and the 6 ohm are connected in series, so they can combine to form a 20 ohm resistor. Let's redraw here. This now become a 20 ohm resistor. And you see this 48 ohm and the 60 ohm also share their two nodes. So we can combine the 48 ohm resistor with 60 ohm resistor. That's 48, 16 over 48 plus 16. This is going to be equal to 12 ohm. So you can replace this as a 12 ohm resistor. And now these two are connected in series. So add them together, you get a 32 ohm resistor. So let's replace them as a single 32 ohm resistor. It will be look like this. This is 32 ohm. So now all of this is combined into a single resistor of 32 ohm. Question C. For question C, we will continue to find the equivalent resistor between terminal A and B, but it may not be very intuitive where you should get started. For example, this is a 30 ohm resistor. If we want to try to see whether the 30 ohm resistor is connected in series with this 30 ohm resistor. Well, you'll see here they share this node, but this node is connected to another wire, to another branch. So they are not connected in series. Well, similarly, we are going to see whether this 30 ohm resistor is connected in series with this one, where is not true as well, because this node is also connected to another wire, so they are not connected in series. So all of these three are not connected in series. So what we are going to do here is that we can see whether they have a relationship as in parallel. Well, let's see. This is node A, because there is no any element on this wire, so this is going to be also node A. And for this node, let's name it node B. And similarly, there's no elements on this wire, so this is also node B. Well, according to our definition of parallel resistors, if two resistors share exactly the same two node, they are in parallel, even though they don't seem to look like in parallel. For example, here, this 30 ohm resistor and this 30 ohm resistor share node A and share node B, so they are actually connected in parallel. And 30 ohm in parallel with 30 ohm, you will simplify this as 30 times 30 over 30 plus 30, and this value is 15. And now we can redraw the circuit diagram. This is node B, and this is node A. This is not changed, and this is our new combined 50 ohm resistor, and this one now is gone. We have the wire connected here, wire connected here. This is node A, node B, and this is 30 ohm resistor. Now we can see that again, these two resistors, 50 ohm and 30 ohm, they share both node A and node B, so they are also connected in parallel. We can combine 50 ohm parallel with 30 ohm. That's 15 times 30 over 15 plus 30. This is 10 ohm. So now the circuit become like this. 12 ohm, 6 ohm, 10 ohm, A, B. So now all of these three are connected in series. So we can combine all of this by add them together. 6 plus 12 plus 10 is going to be, this is 18 and this is 10, so that's going to be 28 ohm. So the Req for this circuit here is going to be 28 ohm. Question P2.16. The equivalent resistance between terminal A and B in figure P2.16 is RAB equal to 40 ohms, and we are going to determine the value of R. This question is a little bit different from the previous ones because we are not going to calculate the value of the equivalent resistor between A and B, but we are given the value, but we don't know one of the resistor value R here. So we are going to find out what's the value of R. Well, even though we don't know what's R, we can still simplify the circuit as what we did for previous questions. So let's assume that we have this is R, and this is terminal A and B. As always, we start from a point that's away from the two terminals. For example, we start from here. So we have 30 ohm resistor and 45 ohm resistor connected in parallel. So that's 30 parallel with 45. That's 30 times 45 over 30 plus 45. And this is equal to 80 ohm. And now we can simplify the circuit. Let's redraw the circuit diagram. This is 20, this is R, this is 70. This is now 80 ohm. We have terminal B here and the terminal A here. So let's continue to simplify the circuit. We have R and 18 connected in series, so together they become R plus 18. And R plus 18 is connected in parallel with the 70 ohm here. So we have R plus 18 in parallel with 70, and we substitute in our formula, R plus 18 times 70 over R plus 18 plus 70. That's going to be, if we simplify this, we're going to get 70R plus 1260 ohm over R plus 88. So now this become R 70R plus 1260 ohm over R plus 88 ohm. And we add the 20 ohm together, we are gonna get the R equivalent, RAB. So RAB is equal to 20 plus 70R plus 1260 over R plus 88. That's equal to 40 ohm. And you can solve this equation. You will be able to get R is exactly equal to 10 ohm. So that's 10 ohm. And we will be able to determine the value of R to be 10 ohm. Now, this is the second type of questions we are going to see in our assignment. That's to calculate the voltage value and current value with equivalent circuit. Generally, we are going to go through 3 steps to solve this type of question. The first is find REQ, R equivalent, to simply a part of the circuit so that we can easily find out the voltage and the current we need. And the second step is to calculate the voltages across REQ. The third step is to calculate the currents. When we know the voltages, we are going to use Ohm's law and current division. So let's see how this works in this example. Find the value of I1, I2 in figure P2.24 and then find the power for each element in their circuit and state whether each is absorbing or delivering energy, and verify the total power is conserved. Well, so the first step is to simplify the circuit. Well, in this case, we have the 5 ohm resistor and the 50 ohm resistor are connected both to node A. This is the same node A. This is also the same node, that's node B. So 5 parallel is 15. That's going to be 5 times 15 over 5 plus 15. And this is going to be 3.75 ohm. So we can simplify the circuit as like this. This 3.75 ohm is 2M, is 4M, and this is plus minus Vx. Well, when we combine these two resistors, we'll see that these two current I1 and I2 are gone for now, but that's okay because we are going to first find out the value of Vx, and Vx is the voltage across the REQ. That is Vx. So how can we find the value of Vx? We can perform the KCL here to find the current flows through this 3.75 ohm resistor, and then using the Ohm's law to find the voltage value. So let's say this is current I 3.75 ohm, and we have the 4M current flow into this node, and 2 amp current leaving this node. So we have 4 amp is equal to I 3.75 ohm plus 2 amp. And you can solve I 3.75 ohm to be 2 amp. So this is going to be equal to 2 amp. So we can easily find the Vx, that's 2 times 3.75 ohm, which is 7.5 volt. Okay. So how should we find the value of I1 and I2, the current value of I1 and I2? Now we know Vx is equal to 7.5 volt. That's also pretty straightforward because we can directly use Ohm's law. So I1 is equal to 7.5 volt, 5 ohm. 2 is equal to 7.5 volt over 50 volt. And this is going to be equal to 1.5 amp. This is equal to 0.5 amp. So by using the formula we learned last week, we can calculate the power used by the two resistors as P is equal to I square R. So P 5 ohm is equal to 7.5 square over 5. That's 11.25 watts. And P 15 ohm is equal to 7.5 square over 15. That's 3.75 watt. And both of these are positive values, so they are absorbing energy. And we also know that the resistors are passive elements, so they are for sure to absorb energy. Now let's calculate the power used by the two current sources. For the current source, we can only use the standard formula, that is P is equal to V times I. So for the 4 amp current source, that is 4 times 7.5, that's 330 watts. And for the 2 amp resistor, that is 2 times 7.5 is equal to 15 watts. And because this is positive, this is negative, so the current is leaving the positive terminal. So for the 4 amp current source, we have negative here and also negative here. So it is the only element in this circuit that has a negative value of power. So it is the only one that is absorbing, that is delivering power. And for all of other elements, they are absorbing power. And when we sum all of this up, we will be able to see the sum of P is equal to 0. For this question, we are asked to find the value of V and I in figure P2.25. So similarly, we are going to go through the 3 steps we introduced for a couple of questions ago, and that's first, find Req to simplify the circuit, and second, find V across Req, and third is to find the current by using Ohm's law and the current diffusion. So let's find the Req first. We are asked to find the value of V. V is here, so let's get started from this side. So we'll see the 10 ohm and 10 ohm resistors are connected in series. So we have them combined as 20 ohm resistor. So this 20 ohm resistor will be in parallel with this 20 ohm resistor. So we have 20 ohm in parallel with 20 ohm. That's going to be 20 times 20 over 20 plus 20. And you will get a 10 ohm resistor. So let's redraw the circuit. the new circuit will be look like this. And this is 10 ohm resistor. So now let's continue to simplify the circuit. The 10 ohm resistor and the 20 ohm resistors are connected in parallel. So combine these two, we're gonna get 20 ohm in parallel with 10 ohm, and 20 times 10 over 20 plus 10 is 20 over 3 ohm. So this is gonna be 20 of 3 ohm resistor. 20 over 3 ohm. So now we have this resistor, we are gonna be able to see this 20 ohm resistor is connected in parallel with this 20 ohm resistor. So again, 20 in parallel with 20 over 3 ohm. So that's 20 times 20 over 3 over 20 plus 20 over 3. And to simplify this, you're gonna get a 5 ohm resistor. So let's redraw the circuit again. Now we have a 5 ohm, 25, we have a 5 ohm resistor. Then you'll be able to see the 5 ohm resistor and the 20 ohm resistors are connected in series. So we can simplify this further to get a 25 ohm resistor. So that's 25 ohm, and this 25 ohm resistor and this 25 ohm resistor are connected in parallel. So we have 25 in parallel is 25, and that's 25 times 25 over 25 plus 25. And this is going to be 12.5 ohm resistor. So let's redraw the diagram again. And this now become a 12.5 ohm resistor. That is still 5 ohm. Okay, so our last step is to combine these two that are connected in series. And that will be a 17.5 resistor. So this is 7.5 resistor. And our goal is to find the value of V. V is here. So V, by simply using the Ohm's law, that's 8 times 17.5 ohm. And you will get V is equal to 140 volts. Now we come to our third step to find the value of the currents. Well, the current is here. Current I flows through 10 ohm resistor and this 10 ohm resistor. So if we want to find I, we need to use Ohm's law, right? So we need first to calculate the voltage across these two resistors. That's V1. And let's assume this is the ground. So this is the V1. And you will find this is node A. This is node B, because there's no elements between these 2 points. So this is also B. This is also B. So this is the same node B. So all of this branch seem exactly the same voltage. So computing the V1 by using this branch here is exactly the same as using the branch here. Because what we know, all of the information we know of the voltage and the current is at this side. So it's the best to make use of the information on this side. So we are gonna also simplify the circuit to make use of the information here. This is 5 ohm, this is 20 ohm, this is 25 ohm, and this is 20 ohm. This is 8 amp. sorry, this is not 20 ohm because we simplify all of this. And if you check the last slide, you're gonna find this is the 5 ohm resistor. When you combine all of this resistor, you're gonna get a 5 ohm resistor. And our goal is to find V1 here. So how can we find V1? Well, we can use the current diffusion. This is Ix to 1 is equal to 8M, and it flows here or here. So we use current diffusion to find, let's say, I1. I1 is equal to 8M times 25 ohm here over 25 ohm plus 20 plus 5 ohm. So it's going to be equal to 4M. So I1 here is equal to 4M. And by using Ohm's law, we have I1 is equal to 4M. Then V1 is 4 times 5, which is 20 volts. So we have V1 as 20 volt. We then use Ohm's law again to find the current I here. So that's going to be I is equal to V1 over 10 plus 10 ohm. That's 20 volt over 10 ohm plus 10 ohm. And you are going to get 1 amp. So the final answer for I is 1 amp. Question P2.30. Find the voltage V and the current I1 and I2 for the circuit shown below in figure B 2.30. For this question, we are going to find V first. So if that's the case, we are going to combine all of other resistors here to make this network of only one resistor. So let's do that. We have 10 ohm resistor and 40 ohm resistor in parallel. 10 in parallel is 40. That's 10 times 40 over 10 plus 40. That's equal to 8 ohm. And similarly for this part, 18 ohm in parallel with 9 ohm. That's equal to 18 times 9 over 18 plus 9, which is equal to 6 ohm. And in that case, we'll combine this part to be 8 ohm, this part to be 6 ohm, and these three are connected in series. So we have 8 ohm plus 6 ohm plus 6 ohm. That is 20 ohm. So now we can redraw the circuit as like this. So this is 20 ohm, this is 5M, and we are going to find the value of V. So V is equal to 5 times 20 ohm, which is 100 volts. If we are going to find the value of I1 and I2, we need to simplify the circuit to a different extent. So in this example, we can simplify the circuit to be like this. And this is 6 ohm, and for the left is 8 ohm, and this is 6 ohm. And we can calculate the voltage drop of 6 ohm. Let's say that's V1. So V1 is 5 times 6 ohm. That's 30 volt. And for V2, that is plus minus V2. V2 is equal to 5 times 8. That's 40 volt. So the voltage drop here is 40 volt from here to here, and the voltage drop from here to here is 30 volt. So then we have I2 is equal to 30 volt for 9 ohm. That's 3.333 amp. And for this part, that's I1 is equal to 40 volt over 10 ohm. That's 4 amp. So that's the value we want to calculate. Question P2.33. Consider the circuit shown in figure P2.33 and find the values of V1, V2, VAB, VBC, and VCA. This question is a little bit different from other questions because this question tests your understanding of the special circuit. There are typically 3 situations you need to pay attention to. The first tab is short circuit. Between points A and B, there is only one wire connecting A and B and no other elements. So in this case, there is no voltage drop between A and B. So VAB is equal to 0. And the current IAB typically is not equal to 0. And the second situation is open circuit. This is terminal A and this is terminal B, and we have a point that's not connected between A and B. So in this case, there's no current, so IAB is equal to 0 because they are not connected, so there is no current flow through A and B, so IAB is equal to 0. But VAB may not be 0. So that's the important point we need to keep in mind. And for the open circuit situation, if you have, let's say this is point A, and this is a resistor where C and D are not connected, and this is resistor B, and this is E. So in this case, if C and D are not connected, and A and C are connected, there may be some other circuit connected here, and the voltage at C is exactly the same as the voltage at point A. And the voltage at point D is exactly the same as voltage at point E. So that's an important point we need to keep in mind. The reason is that there's no current flow through here. No current flows through here, so there's no voltage drop. No voltage drop, so we have VC is equal to VA, and VD is equal to VE. That's an important point to keep in mind. Well, there's a third situation you will typically see in a circuit diagram, and that's important to know. For example, if this is a simple circuit, this is a resistor, and we have terminal C. So here, the node C is exactly the same as node D. So because this is actually, there's no voltage drop here, so VC is exactly as VD. And if there is another terminal here that's E, VCE is just VDF. So VDF is actually the voltage drop across R. That's what we are gonna calculate. So that's mainly the 3 situations you need to pay attention to. So now let's analyze this circuit diagram and see what's special for this circuit diagram. Well, first you will notice is that A and B are not connected. There is an open circuit. That's the second type of situation we discussed. So in this case, when this is open, there is no current flow. I is equal to 0. No current flow means there is no voltage drop between point capital A and this A here. And similarly, there is no voltage drop between B and this B here. So what it means here is that VA is exactly the same as VA, and V capital B is exactly the same as V little b. And for this case, at the point C, exactly let's see here, and because this is a wire that with no element, so this is also C, and this is also C. That's the same node. Okay, so let's get started to try a few questions. First, we are asked to find out what's V1 and V2. We know that this circuit have this part as open, so there is no current flow through here, and all of the current I1 will go through the voltage source, 8 ohm resistor and 7 ohm resistor. No current flows to anywhere else. So it would be super easy by directly use the voltage division to find out V1. Then that would be 30 times 7 over 8 plus 7, and this is equal to 40 volt. And for V2, very similarly, there's no current flow here, so all of the current flows into the 2 ohm resistor. That is 3 times 2 ohm, and this is 6 volt. Now we have V1 and V2. We can continue to find VAB and VBC. So let's draw the circuit diagram again here. In order to find VAB, it's very essential to know where you are going to get started, which method you will use to find VAB. So let's draw the circuit diagram here. This is 8 ohm, 3 ohm, 4 ohm, 2 ohm, 7 ohm, 30 volt, and 3 amp. And the one most convenient way to find the voltage drop between VAB is to use the KVL. And we can use a voltmeter method. So let's imagine this is connected to a voltmeter, V. And with a voltmeter, the inner resistance is infinitely large, we can assume, and there is no current pass through here, and the voltage we measured is VAB. So we can write the KVL equation to express this relationship. That is minus V1 plus V3 ohm plus VAB plus V4 ohm, and this is plus minus, so we have plus V2, that's equal to 0. As we know, there is no current flows through the V3 ohm, no current flows through V4 ohm, and the voltage drop is 0, so both of these are 0. And we also know V1 is equal to 14 volt, V2 is equal to 6 volt. So we can calculate VAB as 8 volt. If we want to find the value of VBC, we need to perform a similar procedure here. So let's redraw the circuit diagram. And this is A, B, and this is C. So we are going to find out the value for VBC. Then similarly, we can use the voltmeter method. That's to connect a voltmeter here. And let this to be VBC plus minus. And let's perform the KVL. So we have minus VBC plus V 4 ohm plus V2 is equal to 0. We know that V2 is equal to 6 volt, and V 4 ohm, because there is no volt drop, that's 0 volt. So we can find out the VBC is equal to 6 volt. So if we want to find out the value of VCA, VCA is here. Similarly, we connect the voltmeter here, and we let this to be positive, this to be negative. We perform the KVL. We have minus V1 plus V3 ohm and minus VCA is equal to 0. And this is 0. And V1, we know that V1 is equal to 40 volt. So we have VCA is equal to negative 40 volt. So that's our VCA and VBC. Question P2.35. Find the values of I1 and I2 in figure P2.35. So for this question, we are going to find the value of I1 and I2. So similarly, we're going to go through the 3 steps. Find Req, voltage across Req, and I by using Ohm's law. So in this question, we are going to find I1. So to find I1, we need to use Ohm's law, right? By using Ohm's law, we are going to perform Ohm's law on the equivalent resistor. So for which part should we combine to be the equivalent resistor? Well, in this case, you are going to combine all of these resistors and imagine the terminals are here. So that's a little bit different from what we do when the terminals are here. So let's get started to try to combine all of these resistors. Well, in this case, this is terminal A, this is B, and this is B. And in this case, this is going to be terminal C. Well, we can see that the 6 ohm resistor and the 12 ohm resistors is still connected in parallel because they shared both A and B. So we have 6 in parallel with 12 ohm resistor, and this is equal to 6 times 12 over 6 plus 12. This is equal to 4 ohm. So we can redraw the circuit like this. Now this becomes a 4 ohm resistor, and now this is 12, this is 6. Okay, and we can simplify this further because we are assumed the terminals are here. And now this to the 12 ohm resistor and the 6 ohm resistor can be combined, and that's That's the same as the result here. That's 4 ohm. So we erase this 2 branch and come 4 ohm. Now, because terminals are here, no any other branch is connected to this point. So we have 4 ohm plus 4 ohm to be 8 ohm. So we can redraw the circuit. This is 8 ohm. So now we can simplify the circuit to be like this. And that would be easy to find I1 by using Ohm's law. So I1 is equal to 20 volt over 8 ohm. So that's equal to 2.5 ohm. Now we can continue to find the value for I2. If we want to find I2, one way that we typically do in the Wheatstone bridge is to perform the KCL here. Let this to be I3 and this is I4. Then in order to find I2, we can use KCL here. We have I3 is entering the terminal, entering this node, and I2 and I4 are leaving this node. So we have I3 is equal to I2 plus I4. So in order to find I2, we need to find out I3 minus I4. So how can we find I3 and I4? Similarly, if we want to find the current, we have to use Ohm's law. So in order to perform the Ohm's law to the 6 ohm resistor to find I3, we need to know the voltage drop between A and B. And if we want to find the value for I4, we are gonna find out the voltage drop between B and C. So we know the resistor value, that's 6 ohm and 12 ohm. So what we are gonna do now is to find the voltage drop, VAB and VBC. So typically in this case, we need to simplify the circuit again to the extent that we can easily find out VAB and VBC. VAB is actually, this is also VAB. That's the voltage drop for 12 ohm. And similarly, VBC is also the voltage drop for the 6 ohm resistor. So let's simplify the circuit by combining these two resistors and these two. Then we will have a circuit with 6 in parallel with 12 ohm. That's 6 times 12 over 6 plus 12, and that's 4 ohm. So this is 4 ohm, and this is also 4 ohm. And this is 20 volt. By using the voltage division, we have this is VAB, and this is VBC. So VAB is equal to 20 times 4 plus 4. This is 4. VBC is 20 times 4 over 4 plus 4. That's 10 volt. And this is also 10 volt. So now we can calculate the value of I3 by using Ohm's law. VAB is 10 volt, so I3 is equal to 10 volt over 6 ohm. And I4 here, VBC is 10 volt as well, so that's 10 volt over 12 ohm. So we substitute in the value into this equation, and we are gonna get I2 is equal to 0.8333 amp. So we can find out the value for I2. For question 2.36 to question 2.39, we're going to use the principles of voltage division and current division to solve the problems. Let's recall. This is R1, R2, R3, and this is the total voltage V. If we want to find out the voltage across R1, we are going to use the formula for voltage diffusion. So let's say the voltage across R1 is V1, then we have V1 is equal to V times R1 over R1 plus R2 plus R3. So that's our formula for voltage diffusion. Now for this question, we are asked to use voltage diffusion principle to calculate V1, V2, V3 in the circuit diagram P2.36. So in this example, we have R1 is equal to 5 ohm, R2 is equal to 7 ohm, R3 is 30 ohm, and the total voltage is 25 volts. So we can directly use this formula here to substitute in the values into this formula and get the answer. So V1 is equal to 25 times 5 over 5 plus 7 plus 13, and you're going to get 5 volt. V2 is equal to 25 times 7 over 5 plus 7 plus 13, and that's 7 volts. For V3, we have 25 times 13 over 5 plus 7 plus 13, so that's 70 volts. So we can easily find out V1, V2, and V3. Now, question P2.37. Use current diffusion principle to calculate I1, I2 in figure P2.37. For this question, let's recall the formula for current diffusion. For example, if this is R1, this is R2, they are connected in parallel. And we have the total current I flows through these two branches, and we can use the formula to calculate current I1 and current I2 based on the principle of current diffusion. So I1 is going to be equal to I times R2 over R1 plus R2, and I2 is equal to I times R1 plus over R1 plus R2. So in this question, we are going to use the current diffusion principle to calculate I1 and I2 in this circuit. So you can see the total current is 3 amp. In this case, that's the current I flows through this branch and divided into I1 and I2. So we have I1 is equal to I times R2 over R1 plus R2. I2 is equal to I times R1 over R1 plus R2. And let's substitute in the value. We are going to get I1 is equal to 2 amp and I2 is equal to 1 amp. So next, question P2.38. Use voltage diffusion principle to calculate V in figure P2.38. In this case, we have R2 and R3 are both connected to these two nodes, so they are in parallel. One way to apply the voltage diffusion principle here is first combine R2 and R3, so we'll get a circuit of a single loop, and then use the voltage diffusion principle to calculate the value V. Now, let's combine R2 and R3. That is 20 times 20 over 20 plus 20 ohm. And this is going to be 10 ohm. So we can redraw the circuit diagram as like this. This is 10 volt. This is R1 is equal to 20 ohms. And the R equivalent is going to be equal to 10 ohms. And this is still voltage V. So to use the voltage division principle, we can write the formula. V is equal to 10 volt times 20 ohms plus 10 ohms, and the top is 10 ohms. So simplify this expression. You have this is 1, this is 3, so V is equal to 10 over 3 volt. Question 2.39. Use the current efficient principle to calculate the value of I3. Well, here is I3. To use the current efficient, we first need to find the current I that's on the main branch, and this current I is divided into I2 and I3. So what's the value of I? Well, I is the current for R1, and we have R1 connected in series with this current source. So I is going to be equal to 30 milliamp. Then we can perform the current diffusion. I3 is equal to I times R2 over R2 plus R3. Substitute in the values. I is equal to 30 milliamps. And R2 is 25 ohm, 25 ohm, 50 ohm. So I3 is going to be equal to 10 milliamp. That's our final answer.